Good afternoon, everyone, or good morning if you happen to be west of where I am. And welcome to the latest in our series of Friday webinars. In this particular edition, we'll be covering the EN50332 test standard for measuring the maximum output levels of headphones and portable music players. And in the series of First Friday webinars, we've done two recently. We did one 2 months ago on hearing aid testing, and one last month by our president, Steve Temme, a nice technical presentation on testing impedance. If you'd like to check out either of those, they are available on our website for download. This webinar is also being recorded and will be uploaded to our website within a certain period of time, hopefully sometime next week. And so if you want to watch it again or send it to a colleague to watch, it will be available for download then as well. So in this webinar, we'll be covering the EN50332 standard and how to measure to it in soundcheck with our package of sequences. The topics for today's webinar: I'll give you an overview of the EN50332 standard in case you're not all that familiar with it. So hopefully, if you're joining this webinar, you have some interest in testing to this standard, and maybe you know a bit about it or have tested to it before. But we'll talk about what the standard is, what it covers, and the latest revision of it. Then we'll get into the soundcheck specific portion of it, talking about the sequence package that we sell for testing to the standard, the requirements for the software and the hardware, and I'll talk about the setup, how to actually connect everything together to perform these tests. Then I'll switch over to soundcheck, and I'll show you how to go about importing calibration and getting everything set up on the software side to be able to perform the test. And finally, we'll go through and I'll run the different sequences just to give you an idea of how it all works. So the standard itself. It's originally a European safety standard by the British Standards Institution, although it's been adopted pretty widely across the, especially the headphone market and people doing portable music players. Really what it is it provides a guideline for measuring maximum output levels. So it's a safety standard, sort of dictating what the maximum output levels of portable music players and headphones, earphones should be, or at least that's what it was originally. In the latest revision, which is 2013, they have removed the limits from the standard. So the interesting part of that is that running this test standard, you'll no longer see a pass-fail at the end because there are no hard and fast limits as dictated by the standard itself. However, in the standard, there are some notes linking to a couple of other EN standards that you see down there below, especially 60065. So there are some requirements in these other documents that you can use the data generated from this test standard to see what you are in compliance with and get some recommendations depending on where you want your devices to be sold. So the EN50332 standard itself is just a measurement standard. It just tells you how to perform the measurements and what data to collect. These other standards and other places, depending on what countries you're working with, will have their own guidelines over what you then need to do with your product to make sure it is compliant. So in these sequences, don't be surprised when you don't see a pass-fail at the end. We are not applying the limits from any of these other standards. That's up to you to decide what you want to actually test your devices to. In the future, if there's some really good harmonization between these different standards that get widely adopted, maybe then we'll add it into the sequences in a later revision. But for now, we'll just be collecting the data, and then you can then decide what you want to measure that data up to. So just as an example, in one of these standards, if your device, the combination of a music player and a headphone puts out less than 85 dBA, then you're fine. You don't have to do anything. If the device puts out between 85 and 100 dBA, then you need to put a different marking on the device. There needs to be something in the software of the music player that gives a warning if you try to play it out at too high a level. So it really depends on, again, what country you are working with and where you want to be able to sell the device. So that's the new part of the 2013 version of the standard. Otherwise, it's pretty identical, except they have now finally added some stipulations for testing digital devices. So the original revision was, I think, 2000. There might have been an even earlier one than that, and then there was one in 2003. So they were old enough that the technology was still relatively young in regards to MP3 players, and especially Bluetooth, USB, other digital devices. So actually in the version of the standard we had been using for quite some time, there were lots of references to magnetic tape and cassette players. Of course, we don't see that too often anymore. And so now we need to be able to test things like Bluetooth, things like USB. And they've added now some instructions about how to go about doing that to test these digital devices. And I'll cover that a little bit in this webinar. There is a test signal that gets used for every measurement that we perform in part of this standard. So it's the same test signal used across all of the sequences. It's a weighted pink noise as specified in the standard IEC 60268-1. So it starts off life as pink noise. It then has a spectral characteristic applied to it that's meant to mimic program material such as music. So it doesn't have the same spectral shape as normal pink noise would. Also, they apply some soft clipping to it to reduce the crest factor. So the crest factor is between 1.8 and 2.2. So you can see a copy of the waveform down below, and you can sort of see how it looks very squared off as it's been clipped to produce that specified crest factor. And that actually works quite well, because if you do pull up a waveform of modern music and look at it, it looks kind of squared off like that as well. So that's really what it's meant to simulate. So some of the tests in this standard are performed electrically. We'll be doing some measurements of the headphone amplifiers on the music players. And then many of them are done acoustically through ear simulators when we're testing the headphones. For any of the acoustic measurements that we do, they are all made the same way. So we record the signal in through the artificial ears, and we analyze that signal using a 1/3 octave RTA. So that gives us the 3rd octave spectrum. That 3rd octave spectrum is A-weighted for any of the acoustic measurements. So we apply the A weighting, and we also apply a correction for the head and torso. And the standard way we do this in the sound check sequences is apply a free field correction, although the standard does allow for a diffuse field correction to be used if you'd like to apply that. The differences are not that big. You won't see a big change between the two, but it is optional. Once you have the corrected spectra, A-weighted, and the free field correction applied, we then take that spectrum and take the power sum of it between 20 hertz and 20 kilohertz. So basically that gives us the total sound pressure level for that corrected spectrum. And then that becomes our final value for a couple of the sequences. So this is the process that you'll see done in a number of the tests kind of throughout the standard. So the standard is split up into 2 parts. There's a -1 and the -2. The -1 portion of the standard covers portable music players and headphones or earphones that are sold as a combined unit. So in the original standard, this was a little vague about when this applied, but basically if you made an MP3 player and bundled it with a set of earphones, then you would test it to the -1 part of the standard. In -1, we test the 2 of them together. However, in the more recent version of the standard, they've put in a little bit of extra text that says if the devices can be separated, meaning that your music player has a headphone jack where you could replace the stock headphones with something else, then you should test to the -2 part of the standard. So we'll get to the -2, but that's where we test the devices separately. So it's really up to you if you want to do both. You could test, so if you're making, let's say, a smartphone, and you sell it with a set of earphones, you could do the -1 test and test them together, and then also do the -2 test if you needed to measure them separately. Sort of depends on how your units are going to be sold and marketed. So to perform this test, we take our stimulus file, the weighted pink noise signal that I was showing you earlier, and we load it onto our portable music player. And again, this could be a smartphone, could be an MP3 player, it could be a tablet. There's a number of devices that fall under this category. So we load the file onto the device, and then in the software of the device, we need to set everything to produce the maximum output possible. So that means turning the volume up to its maximum level. It also means setting all of the signal processing to produce the max output. So if it has some DSP to boost the bass, you have to turn that on. If it has some equalizers you can go into, you're supposed to set everything to its absolute maximum so that you produce the highest output possible. So we play back that stimulus signal from the device through the headphones and then measure the output of the headphones through the ear simulators. We do this over 5 trials. And the reason that we do these measurements over 5 trials is that when we're dealing with headphones, there's a lot of variability in the fit. And as you change the fit, the way that they sit on the ears or in the ears in the case of earphones, you can change the way that the sound pressure levels appear. So we perform the same measurement 5 times, removing the headphones through each iteration, placing them back on so that we average out the fit variation of the device. So you'll see this again in the Dash 2 part of the standard, that we perform the same measurement 5 times and then average the final result. In the Dash 2 part of the standard, we now test the devices separately. So if all you do is make headphones, then you'd be interested in the Dash 2 part of the standard here. Or if you are making a smartphone and you need to test it by itself, then the Dash 2 part of the standard is for you. So here we're going to be measuring them separately. And so we have a few different sequences that will make up this part of the test. So one, we test the music player itself. And so for that, just like the Dash 1 part of the standard, we load the stimulus file onto the device, and we'll set everything to maximum output again. This time, instead of plugging in headphones, we take the output of the headphone amp and we load it with a 32 ohm resistor. So this resistor is there to serve as a replacement for the headphone load. 32 ohms is kind of an average headphone impedance value, so it will get the headphone amp to operate how it would with a set of headphones attached. So we then measure the voltage across that 32 ohm resistor back into our system. So that's what we're going to be looking at, is the voltage output of the music player device across that resistor load. When we're looking at the headphone part of the Dash 2 standard, we split it into analog and digital. So for analog headphones, the standard states that we have to connect the headphones to an amplifier that has less than or equal to 2 ohm output impedance. That pretty much rules out a lot of standard headphone amplifiers. So for instance, if we wanted to just use the headphone amp on our sound card, that's not going to meet this criteria. It'll typically have greater than 2 ohm output impedance. So we're left with a couple options. One, we can look for a headphone amp that does have a low enough impedance, and there are a couple of them out there. Or we can use a power amplifier. So a power amp is typically going to have a low enough output impedance, but usually rather high gain. It has way more power than we need to power headphones. So if your amplifier has variable gain, you can turn it down low enough so that it'll behave nicely with the headphones. So either way, you can look for a headphone amp. You can talk to us if you need some recommendations, or use a power amplifier. So for this test, we'll be playing the stimulus signal directly from soundcheck, and then that will be sent through this amplifier to the headphones, and then we're going to monitor the sound pressure level through the ear simulators. And again, we'll be doing the 5 trials to average out the fit variation from one iteration, from one part of the loop to another. And here, what we're going to calculate is what stimulus voltage is required to produce 94 dBA at the ear simulators. So we'll be doing the measurement with a known voltage output, check what the sound pressure level is, and then use that to calculate what voltage would be required to produce 94. So that's really what the Dash 2 headphone standard is all about, is listing what that voltage is for the left and the right ears. On the digital side, so again, we're talking about things like Bluetooth headsets, USB, could be headsets, headphones, whatever it happens to be. Here we're going to send the stimulus signal digitally to the device under test. So nothing analog, nothing dealing with voltage. And that's why the original standard didn't really cover digital headphones, because everything was stated in terms of stimulus voltages, which just didn't really apply to a digital device. So now the standard calls out for digital headphones to play the file at a level of -10 dB full scale. And in this case, that full scale is referencing the RMS level of a sine wave for the 0 dB reference. So we play the stimulus signal digitally to the device under test at -10, and then we're going to monitor the output sound pressure level through the ear stimulators again. So in this way, the test is actually a little bit more similar to the -1. So instead of calculating a stimulus voltage, here we're just going to be recording the sound pressure level. And at the end of the test, we're going to report back what the sound pressure level was when playing that digital stimulus. And just like the -1 and the analog headphone portion of the -2, we'll do 5 separate trials to average out that fit variation. So here's how that all applies to testing this in SoundCheck. So in SoundCheck, we have a number of standard sequences that are available for purchase, different standards packages. And one of those is the EN standard, and that is module 3102. So to run any of these standard sequence packages, you purchase it from us. We send you the new status.dat file that unlocks that module and send you the sequence files, and that will allow you to run the sequences. So once you purchase a module 3102, you'll be able to run both the -1 and the -2 portions of the standard. Other software requirements in order to run these test sequences. You will have to have SoundCheck 13, which is slated to be released very soon, just in a couple weeks. And the latest revision of the standard is only going to be available in SoundCheck 13, so you'll have to upgrade your systems. You'll need at least the SoundCheck Plus package. The SoundCheck Plus package includes some of the virtual instruments, and that's principally what you'll need to run these sequences, things like the signal generator, the multimeter. You'll also need post-processing statistics, and those are all modules that are part of the SoundCheck Plus package. So as long as you have at least that or any of the higher packages, you'll be fine. And then you also need module 2005, the real-time analyzer, to run these sequences. That gets heavy usage to measure those third octave spectra. On the hardware side, if you're going to be running the -2 portion of the standard, and you're going to be running the analog headphone sequence, you will need a SoundCheck audio interface with at least 4 inputs. I'll go over the reason for that in just a little bit, but that's the only sequence that needs that. If you're not going to be running the analog headphone, if you're just going to be running digital or testing the music player, then you can get away with just a 2 input device. So if you're doing the headphone portion, you need 4. You'll also need a head and torso stimulator that's compliant with IEC standard 60318-4 and -7. And so examples of that would be the B&K hats or the Gras Kimar. There might be a few others out there as well. But in order for them to work with the EN standard, they have to be compliant with that IEC standard as well. You'll need some sort of signal conditioning for your hats and microphones. Depending if they're 200-volt polarization, you could use our Listen Sound Connect to power them. If they're pre-polarized, you could use our Listen Amp Connect to power them, or any other signal conditioning that you have. And then if you're going to run the -2 analog headphone test, you'll also need, like I said before, an amplifier with less than or equal to 2 ohm output impedance. So that would, again, only be if you're running the headphone portion of the -2 standard. So let's go over the connection diagrams for how these things are set up, just to give you a visual here. So if you're testing the -1 part of the standard, again, that's where we're testing both the music player and the headphones together. Then we have our music player down at the bottom, connected to the headphones on the head and torso, and then the head and torso through some signal conditioning back to the sound card. So pretty basic setup there. So in our SoundCheck system, we're only using 2 inputs, no outputs, because the music player is providing the stimulus itself. Now, if we switch over to the -2 side and we're testing just the music player by itself, here we have no acoustic test happening at all. It's purely electrical. So we have the portable music player connected back to the sound card, and you'll have your 32 ohm resistor across the output there. And the diagram shows the left and the right connected. You could do that, but the sequence is only going to actually use one channel. The standard assumes that the left and the right are going to be similar enough in level that you only need to test one. So for our purposes in our sound check sequence, it's just looking at the left output of the device. So that's a pretty simple setup. Where it gets a little bit more complex is when we get into the analog headphone test here. So starting at the big computer you see there, and where it says sound card output, we'll connect the output of our audio interface to our amplifier. And again, this could be a headphone amp if it has low enough output impedance, or it could be a power amplifier. So you'll have your two channels, and your headphones will be connected to the amplifier. But you'll also need to branch off and take two signals, the left and the right, back to the sound card from the amp. So we have this electrical loopback going on if you follow those red and blue lines. The reason for that is that the standard calls out looking for the voltage at the headphone. So we could just calibrate the headphone amplifier ahead of time, and we would know what the voltage is at the amp, but we wouldn't know what the voltage was when it's loaded with the headphones. So the purpose of having the loopback built in is that we can then monitor the voltage while it's under the load of the headphones. So we'll know exactly how much voltage the headphones are seeing, and we can adjust for that. So the test sequence has basically some calibration built into it. So you don't need to calibrate the headphone amplifier ahead of time. It's done at the very beginning of the test. The reason for that is that as we switch from one headphone to another, they might have different impedance characteristics, and that will change how the amplifier behaves. So as we switch from one type of unit to another, we don't have to redo our calibration. The sequence just takes care of it for us in real time. So that's why you need your 4 inputs. We'll have the 2 inputs from the loopback, and then 2 inputs coming from the head and torso ear simulators going to the other channel. So 2 channels acoustic, 2 channels of electrical. On the digital configuration, we will need to connect our digital device to the SoundCheck system. Now this is pretty easy in SoundCheck because we are a software-based system. We can easily access any device that shows up as a Windows audio device. So if you have a USB headset that you plug into your USB port, typically it's rather plug and play, and it immediately shows up as a Windows audio device. Once it does that, we can see it in SoundCheck, and then we can communicate with it digitally. So it's pretty easy to be able to send a stimulus signal directly to a USB device. If you're doing Bluetooth, it just requires one extra step because you'll need some sort of interface. Now, it might be built into a laptop. Some of them have Bluetooth. Actually, a lot of them do nowadays. And so you can see that, and it shows up as a Windows audio device. Or if you don't have it built in, you could have like a USB Bluetooth dongle that you use to pair to your headset. Either way, once it's connected, you can see it as a device, and we can communicate to it digitally direct from SoundCheck. From there, it's just like testing the analog headphones. Once the headset is on the head and torso, we connect it back through some signal conditioning and then back into our sound card. And so that's where we'll be doing the digital test. And that can either be stereo or mono, so depending on how the device is set up. If it is mono, we just ignore one of the channels for the test. All right, so now I'm going to show you how all of this works in SoundCheck. I'll share my screen with you. SoundCheck 13, you get a little sneak preview of what SoundCheck 13 is going to look like. So let me show you first the sequence package. So here's the folder that we will send to you when you purchase the EN sequences. So in there we have a sequence for -1, or a folder for -1, and a folder for -2. So inside the -1 folder, here are your stimulus files. We have a WAV file version and an MP3 version. Now the WAV file version should be used in almost every case. The reason that we supplied the MP3 was that when we first developed sequences for this standard, not every MP3 player out there supported WAV, strange enough as it seems. Nowadays, I think pretty much every device can play a WAV file. So if you can, take the WAV file and you'll load that onto your device to run the -1 part of the standard. So remember, we're testing them together, the music player plus the headphones here. So I have this file. I've loaded it onto my smartphone, and that's going to be our device under test for this part of the standard. So we'll start here in the -1 folder. There's one sequence, just called -1. And you'll get this sequence document that opens up at the beginning that gives you full instructions about how to set everything up, how to calibrate it, what all you need to do to run the test. So as a reminder, here's our setup diagram. We have our portable music player, in this case my phone. I have a set of headphones connected to it. They are not the headphones that came with the phone, actually. They're a set of circumaural headphones. And I have them on my fixture here, and then going back into my sound card. So our only calibration we need to do for this test is calibrating the left and the right ears, because we're only using the 2 inputs. So we go up to our calibration, and the 2 signal paths that are being used on the input side here are ear sim left and ear sim right. So we go to those, and then we run our calibration. I'm not going to run through that right now. We have a whole separate webinar that covers all the different types of calibration. If you need a little refresher, you can walk through that for calibrating microphones and the ear simulators. So in this case, I have my sensitivity for my left ear, and then here's the sensitivity for my right ear. So they're all set. They're ready to go. So I'll pull up the sequence here so you can kind of watch it in real time. One of the cool new features in SoundCheck 13 is we can leave the sequence editor open while we're running a test, and it'll actually show us what step we're on at any given time. So when we're ready to start the sequence, just hit the start button here. All right, so we need to start the stimulus file on the device. Let me pull up my phone here, make sure that the volume is set to maximum, and just hit play. Now you could make sure you run the device or the file from the very beginning and try and time it out. Or what I do is I just set it to play in a continuous loop, so I don't have to worry about continually resetting the file. So I'll hit play. The stimulus file is playing now, and then when you're ready, you hit enter. So make sure the headphones are securely on the fixture. So typically this test runs for 30 seconds for each trial. In the interest of time savings in this webinar and not sitting around, I've shortened that to 5. So we'll get through this a little bit quicker. So there's our first trial after our 5-second measurement. We get our corrected spectra. So these have been corrected for the A weighting as well as the free field correction for our head and torso. They've both been applied. Those spectra are power summed over 20 hertz to 20 kilohertz, and those are the values that we see down here called LAEQ. So here's the value for the left and the right in dBA. Now here, we're going to keep track of a running average as we do the successive trials. So to run the next trial, we need to remove the headphones and place them back on the fixture. So that's going to average out our fit variation. So I fixture them there, and then we hit enter, and that's going to start our next trial. So again, we get the RTAs. They come up and measure the spectra, and it does the calculation. And you might have noticed the spectrum actually changed there just a little bit. And now here's our new average. So I'll move them again, and we'll get through the last couple trials here. There's the third. And the fourth. You can see how long this would have taken if I had kept it at 30 seconds for all of our measurements. And our last one, the fifth. So at the very end, what we get here, let me turn off my stimulus file. We get the LAEQ mean value, so that's the average over the 5 trials for the left and the right. And they ended up being 90.7 and 90. So if I went back and referenced those other standards which have their recommendations of what you need to do with your products based on these results, I could then see that, okay, it's above 85, so then there's something I will need to do in order to sell my product in certain countries. So you can take a look through those standards and figure out what your next steps are. But here's the data you'll need to then take a look and figure out what needs to be done. Now, if you're ready to run another test, if you have a second device you want to measure, before running the sequence again, we need to reset the stats. So the statistics that are running during the sequence are in a loop. In this loop right here, you see there's a statistics step here. And it's keeping track of that running average. And if we don't reset the stats, we'll end up including the data from our previous run in the next run. So to reset the stats, it gives us a little information here. The easiest way to do that is change this number in the lot field here. Just change it to anything else. And then you'll get a message here that these statistics have been reset. So at that point, you'll be able to start over, run the test again, and now you can measure another device. So that's the -1 part of the standard. It's pretty straightforward, easy to run once you have the file loaded onto your device. Let's take a look at the -2 portion. And here we'll start with the music player sequence. So just to give you a refresher on the setup here, we'll have our music player, in this case my phone, connected across a 32 ohm resistor and then plugged into our sound card. Let me just redo my cabling here. There we go. Now, this sequence is pretty straightforward. It's rather small, and we only have one input. So we're just monitoring the level coming back from the phone in this case, and we're measuring it through the signal path direct in 1. So as far as calibration goes, there really isn't any. The only step you need to do is go to direct in 1 here on the signal path and make sure you have it set to the appropriate hardware channel. So I have my device plugged into input 5 on my RME card right now. The nice thing about using the direct in 1 is it's a protected signal path. We started including protected signal paths in, I believe, SoundCheck 12, or maybe it was even 11.1. And the protected means that it's locked down. You can't change the sensitivity or the device, which is ideal in this case, because we want to use unity cal, 1 volt per volt for the sensitivity, because what we want to monitor here is what voltage is being produced by the device under test. So by leaving this all set to unity, we'll be looking at just the voltage coming into the system. All right, so when we're ready to start, click the start button here, and we get a message that says the volume on the player should be set to maximum. Again, just like the -1 part of the standard, everything should be maximized. We need to start the stimulus file, get that going again. And remember, this is a purely electrical test. There's nothing acoustic. So if you hear the stimulus, something is not hooked up right. So now hit enter and the test begins. And we get our final result here at the end. So we just monitored the level coming in, and there's no weighting curves being applied here or anything. It's just straight up voltage. So it's saying maximum output voltage. Now that is RMS that we're looking at. It's not peak. So the max RMS level here was 165 millivolts. So that's our information that we need to then take for reporting and figuring out what needs to be done with our product. So the music player sequence, pretty straightforward, pretty easy to run. Let's get into the slightly more complicated example, which would be the analog headphones. So when we go to launch this sequence for the very first time, you may have seen this dialog before if you've been using SoundCheck 11 or SoundCheck 12. And this just means that we have some signal paths in the sequence we're trying to open that are not part of our current system configuration. And this is all in the sequence documentation. It actually guides you through this whole process and tells you exactly what to do. So here, what we need to do is add these signal paths to our system. So we just click the drop down, say add to system calibration, add to system calibration. So now our system will have these signal paths called loopback L, loopback R. Hit OK, Ask if we want to import the calibrated device file. Usually that's a pretty good idea because chances are you might not have the calibrated devices that were used for these signal paths. So I'll hit yes. But in this case, these two signal paths are just using UnityCal, which we do already have. So I'll just hit no. Get back to that in just a sec. So when you import the calibration, you will get the calibration editor will open for anything that you need to finish configuring. So in this case, we now have our loopback L, loopback R that are going to be used for this test. And we need to tell SoundCheck what hardware channels to use for those two. So just click the drop down and select what you'd like. In my case here, I have them connected to input 5 and input 6. Once those are set, then we can hit OK and click Save. So looking at our diagram again, remember we have the output connected to our headphone amplifier, and then the headphone amp is split between the headphones and another path that's going to those two loopback channels that we just configured. So I have, on my system, the ear simulators are going to inputs 3 and 4, and I have my sound card loopback here going to inputs 5 and 6. So that can be whatever hardware channels you want. These numbers here are just sort of suggestions. All right, so let me do just a little bit of check here, make sure this is all configured correctly. Okay. Now I just need to redo my cabling and connect my loopback as well as my headphones to the headphone amplifier. Once that is set, then we are ready to go. So I set my headphones, click Start. So the first thing that this sequence is going to do is it's going to check the gain of the amplifier while it's loaded with the device under test. So it's going to use those loopback channels first. So it's going to play the file through the signal generators, and then we're going to see the result come back here on the multimeters. So it's checking the gain of the amplifier. Once it does that, it calculates the gain and then feeds that into the sensitivity for those two channels. So now we have a corrected sensitivity, and we know exactly what the voltage is going to be sent to the headphones even while it's under load. So that's really the self-calibration procedure that gets done at the beginning of the test. All right, so now we're going to do the acoustic part. Here, so we're going to play the stimulus signal, and we're viewing the ear simulator levels on the multimeters. This allows us to move the headphones around to produce the maximum output possible. So just kind of reposition them a little bit and see if I can get that right one just a little bit higher. Yeah, that's pretty good. So once you have them in a stable position where you think they're producing their maximum output, just hit Enter, and then the main part of the test will begin. So now it's playing the stimulus signal, and we're looking at the level on the RTAs. And again, this would normally be a 30-second test that I've shortened down. And here we get our result. Let me just run one more iteration through the loop. So we reposition the headphones, put them back on. So just like the Dash 1 part of the standard, we're going to run these multiple trials. And again, we get the instruments that come up that will help us position the headphones to produce their maximum output. And then we hit Enter, and the next part of the test begins. So this will run through and do the 5 trials. So the values we're going to get here, I'm just going to abort out of the sequence. We don't need to finish running through all 5 trials. But basically what we're looking at is this SPCV value. This is the voltage required to produce 94 dB SPL, or dBA rather, for this particular device. So it's calculating that each time. We're playing a known voltage, looking at the sound pressure, and then calculating what voltage would be required to produce the 94. So for the left, it's 118 millivolts. For the right, 131 millivolts. We average those values over the 5 trials. So here is the average for the 2 trials that we've done so far. At the very end, we will get this display here that gives us the final 2 average values. So that's the output of the analog headphone sequence, is that you get this SPCV value for the left and for the right. So the SPCV stands for Simulated Program Characteristic Voltage, in case you were curious. That's just the abbreviation that they made up for the standard. All right, so that's our analog headphone sequence. And again, it runs in the 5 trials, just like all the other measurements that we do here. So last, I wanted to show you the digital headphone sequence. I'm not actually going to run it, but I just wanted to show you how it works. So in this sequence here, we're going to be connecting digitally instead of through a headphone amplifier. So to do that in SoundCheck, we need to have our digital devices configured in our hardware editor. So just to show you the 2 that I've created on my system, I have these 2 here called USB headset left and USB headset right. And so they are connected to my USB headset here. And it's a digital device. So I set it to digital, which means my units are going to be in full scale instead of voltage. So just by having these channels here, now I have them available and can communicate directly with the headset. So once you have those in your hardware, this sequence uses 2 signal paths called digital headphone left and digital headphone right. So all we need to do in the calibration here is assign them to our hardware channels. So here's my USB headset left and USB headset right. So now if we send any signals to these signal paths here, they will appear right at my digital headset. And so again, this could either be, this is a USB headset, this could also be a Bluetooth dongle just as easily. And for calibration, the only thing we need to do here is make sure that the digital level is assigned to full scale. And also, we need to set the sensitivity. It'll be set to 3 dB to get the offset to be the sine wave reference. Remember I mentioned that earlier, that the reference for the full scale for this particular standard is in reference to the RMS level of a sine wave rather than a square wave. So to change that, we'll change the sensitivity here to 3. Once you have that configuration, the sequence can play directly out of the digital headphone signal path. So it performs the test very similarly to the -1 part of the standard, actually. So it plays the stimulus file through the signal generators at a level of -10 dB full scale, and then it's going to check the output on the RTA and give you the 3rd octave spectra that get corrected, and then we'll look at the total sound pressure level averaged over the 5 trials. So sort of a hybrid between the -1 and the -2 analog headphone portion. So pretty easy to set up here and communicate directly with the digital devices. There's really no specialized hardware you need. As long as it shows up as a Windows audio device, we can connect to it directly here in SoundCheck. All right, I'm going to go back to our WebEx screen now. And if you have any questions, we'll try and catch up on what people have submitted thus far. Or if you have anything else you'd like to ask now, please feel free to do so via the Q&A box.